Alright, this video is going to be on drawing Lewis structures. So we know how to draw, like, just for an element. For example, if we have calcium, then we know how to draw that. But now we're going to look at Lewis structures for a molecule. So we're going to be looking at a whole compound. So when we draw those, we're going to take a look at there's about 4 different steps that we're going to look at in order to make sure that we get the correct structure. So the first step that you want to do every time is going to be to figure out the number of valence electrons. Okay, secondly, you're going to want to determine the central atom. And this is generally the least electronegative. So when we looked at those electronegativity values that are on that chart when we talked about bonds being polar or nonpolar, you want to pick the one that's least electronegative most of the time. And then you want to arrange the other elements around it. And form bonds between those. Okay, the next thing you want to do is add the remaining electrons to complete the octets. And then you're going to check to make sure that you have all the available electrons and you don't have too many or too few. Now, most all the elements are going to want an octet. There are a few exceptions. Hydrogen is only going to get 2 valence electrons, so it doesn't get 8, and that means hydrogen can never be in the middle. When we look at column 2, this is going to be things like beryllium, magnesium, calcium. They are only going to want 4 valence electrons, meaning they're not going to have an octet. They only want 4 to be full. Column 3, things like boron, aluminum, gallium, they're only going to want 6 electrons. So those 3 exceptions are never going to be having an octet of electrons. Alright, so let's look at perhaps NH3. Okay, so we're going to figure out our valence electrons. So N, I have 1 of them, and it happens to be in column 5. And then hydrogen, I have 3 of them, and they are in column 1. So it means all together I'm supposed to have 8 valence electrons. Alright, and between N and H, N is going to be in the middle. And then we're going to put either a pair of electrons, so we're going to have the H's, 1 on each side. You can either do a pair of electrons, or it's perfectly acceptable to do bonds, because a pair of electrons is a bond. Okay, so I have arranged all the other elements around the center, and I have formed all the bonds. So I've done step 3. Okay, then I'm going to add any remaining electrons. So I have 2, 4, 6. In order to get 8, I only need 2 more. So now everybody's got an octet, and that would be my structure for NH3. Okay, we'll do another one. How about we do CCl4. So I have 1 carbon and I have 4 chlorines, and carbon is in column 4 and chlorine is in column 7. Alright, so when I look at their electronegativities, carbon is least electronegative, and if you ever have carbon, it always goes in the center. Then I'm going to put chlorines on either side. So I have 2, 4, 6, 8, so I have a lot of electrons left, so I want to complete my octet around all of those. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So that would be all of the ones that I would need. Okay, how about we try CS2? So I have 1 carbon in column 4, and I have 2 S's and they are in column 6. 16. Okay, between carbon and sulfur, carbon is least electronegative, and as I said before, carbon always goes in the middle. And I'm going to put a sulfur on each side, and then I have to give everybody an octet. So we're going to fill it up with the lone pairs. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, I have too many. What this tells me is that I'm going to have a multiple bond. So these are showing a single bond where I'm sharing 2 electrons. I can also have a double bond, which means there'd be 4 electrons, or I could have a triple bond where there would be 3. So when you end up with too many valence electrons, that signals you need a multiple bond. So what I'm going to do is I'm going to get rid of a pair. Let's say I want to make the multiple bond here. I'm going to have to get rid of a pair on each one of those. Now I'll count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. Again, too many. So then let's say maybe I'm going to put the double bond here, and again I'd have to get rid of another pair on each one. 4, 6, 8, 10, 12, 14, 16. Like that. Okay, how about we try N2? So 2 N's and they're in column 5, so it'll be 10. So N to N, and then give everybody an octet. 2, 4, 6, 8, 10, 12, 14. Oh, way too many. So I'm going to need a multiple bond. So I'm going to put my bond in and get rid of a pair on each one. 2, 4, 6, 8, 10, 12. Still too many. Get rid of a pair on each one and make another bond. So 2, 4, 6, 8, 10. Now the triple bond is the most that you can have. We don't have like a quadruple bond. Okay, how about we try SO2? So 1 S, 2 O's. S is column 6, and O is also column 6. Okay, and then between S and O, we're going to put S in the middle, O on either side. Give everybody an octet. So far we haven't had any that wouldn't get the octet, but keep in mind if you had something that was from column 2 like beryllium or magnesium, or column 3, or any ones with H, like here I didn't give H I didn't give H an octet here. Alright, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So again, I'm going to need a multiple bond. Let's say I'm going to place it here. Get rid of a pair on each one. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so I have a double bond here, single bond here. Now I have another structure that is possible. And that other structure that's possible would be putting the double bond on this side. So it would just be flipped around. And these two are called resonance structures. And a resonance structure is when you have more than one structure possible. You have to have a multiple bond that you could move from one side to the other. So instead of being on to this O, it's actually to this O. So we would have two different structures that are possible. Alright, and my last structure is going to be FNO2. One F, one N, two O's. Fluorine's column 7, nitrogen's column 5, oxygen's column 6. So 17 and 7 is 24. And just to make sure here, when I am talking about the column numbers that they're in, so 1, 2, 3, 4, 5, 6, 7. So here's the fluorine in 7. Nitrogen was in 5 and oxygen was in 6. So you count 1, 2, 3, 4, 5, 6, 7, 8. We can only have 8. We ignore those transition elements. And when I am talking about those electronegativities that I'm looking at, so we are dealing with N, O, and F. So N is a 3, O is a 3.5, and F is a 4. I'm going to put N in the middle because it's the least electronegative. So each time when I was picking out that central atom, like between carbon, which is 2.5, and chlorine, which is 3, I was putting carbon in the middle because it was least electronegative. Alright, then I gotta give everybody an octet. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so in this case I'm going to have a multiple bond. It's not going to be to the fluorine because fluorine would only like to form one bond, because all by itself fluorine has 7, so this is the only one that could form a bond. So I'm going to want to put that double bond to one of the O's, and I'm going to get rid of a pair on each one when I do that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So my structure is going to look like N, O, O, F. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I would have a resonance structure in this case. My resonance structure would be putting the double bond on the other side to that other O. And you might say, well, does N still have an octet? Yes, it does. 2, 4, 6, 8. So the N still has an octet. And each one of my O's, 2, 4, 6, 8. This O, 2, 4, 6, 8. This F, 2, 4, 6, 8. So everybody has an octet and is happy. Alright, that's quick lesson on drawing Lewis structures.